Hi everyone, I hope you all are doing good. So this is the second video in the series. So far we have studied about the central tendency and the dispersion. In today's class we will be studying about the correlation. In the concepts we have studied so far, we have only taken into consideration one variable. That means we just took the X series and we grouped them together and called it as frequency distribution, and we classified them and called it as class intervals. In today's class, we will be considering two such variables and try to understand the relationship between the two variables. We will be studying about correlation and the types of correlation and different ways of measuring the correlations. When we speak about correlation, we can take a lot of examples wherein two variables are dependent on each other. So correlation is studied between two variables in any system. For example, let's consider the environment. If the pressure increases, the temperature also increases. Another example is in the market. If the product is available in huge quantity, the prices will be low. If the product is available rarely, sparsely, then the prices will be higher. Let's jump right in. I'll share the screen with the material. Okay. So here is the definition for correlation. The definition says that the correlation is an analysis of the covariation and relation between two or more variables under consideration. Whenever we have a system consisting of two or more variables, when I say variables, these are all the factors that show some attribute of the system. For example, temperature, pressure, humidity, heat, all of these can be different variables in the environment, right? So they might be interdependent on each other. Like I said, the temperature and pressure, they are interdependent. If the pressure increases, the temperature also increases. Whenever we have a system and two variables are depending on each other, we would want to measure the dependency. How strongly are they dependent on each other? Or is the dependency positive or is the dependency negative? The dependency would be positive when both the variables are increasing together, like the temperature and pressure. In some cases where the value of X is increasing, the value of Y will decrease. That is called negative correlation. And we'll be studying about all those types soon. In the definition, we have to pay attention to these two key terms, covariation and relation. Covariation gives us whether the two variables are varying together or not, either in the positive direction or in the negative direction, but are they varying at all? And the relation gives us what is the strength of the variation between the two variables. We measure the correlation using a coefficient which is denoted by the letter R. And there are different types of correlations. The first one is negative correlation. This is the kind of correlation I mentioned in the example. In this kind of correlation, the deviation of the two variables happen in the opposite direction. We can take the example of production of a particular item and its price. The more that item is produced in the market, the cheaper it is going to get. The rarer the item is available in the market, the costlier it will get. We can think of an example of the diamonds. Diamonds are too costly because they are rarely available in the market. They are not produced in huge quantity. So this is an example for negative correlation. And for positive correlation, the deviation between the two variables happen in the same direction. That means if the value of X is increasing, the value of Y will also increase. And in that case, the value of R is always going to be greater than 0. As an example, all the cooking material that we buy from the market are available always. So because they are more in demand, the supply is also going to be there. There will be some utilities which we don't use often. So those particular item will be supplied in small quantity because there will be no buyers, and then the shopkeeper will have to incur the loss. Then we have linear and non-linear correlation. To understand linear correlation, we can take this to examples and understand it. See here, there is, for every increment in X, there is an equal proportion of increment in Y, and that proportion is 1:5. So if X is 1 here, X is increasing consistently from 1 to 5 with one increment in each step, and Y is also incrementing in 5s. So this is linear correlation. Why do we call it as linear? You can see the word line here. uh, why do we call it as linear is if we plot these values of x and y on a graph, we will get a straight line. We will get a straight line like this, and that's why we call it as linear correlation. Then we have non-linear correlation. It's very simple to understand. For every increment in x, there is no proportionate increment in y. Here the difference from 7 to 5 is different from the difference from 25 to 7. So this is an example for non-linear graph. If we plot these values in the graph, we will not get a line, we will get a zigzag path. That's why this is called as non-linear correlation. Then we look at the properties of correlation coefficient. The value of R will always lie between -1 to +1. It is not going to be lesser than -1. It's not going to be more than +1. So it will, if it is -1, it's a perfect negative correlation. If it is +1, that means a perfect positive correlation. If it is a 0, that means there is no correlation existing between the variables x and y. If it is greater than 0 but not exactly 1, then that's a positive correlation, not perfectly positive but positive. If it is lesser than 0 but greater than -1, that means it's a negative correlation. And the change of scale or the origin does not affect R. What this means is, if you change the scale, so let us take the example of this correlation. If I plot the graph and instead of choosing 0 as my origin, I choose 3 as the origin, or any value in this x series, that is not going to impact the value of R. It is still going to be a straight line. That is not going to change the value of R. And scale, if I choose to select different scale like 1, 1.52, 2.53, 3.5, if I chose a different scale between 1 and 5, that is still not going to affect the value of R. Change of units of measurement does not affect R. Let us consider this example and let's assume these are all weights. Every 1 kg increase in X will impact in 5 kg increase in Y. So if we change the kg to pounds, it will still not make any difference for the constant, the coefficient of correlation. So that is what is meant by the third property. First property says that the value of R lies between -1 and +1. Second one states, second and third one say that the scale, the origin, or the change of units of measurement will not impact the value of R. We have three different ways of measuring the correlation between the two variables. The first method is scatter diagram. The second method is Karl Pearson's coefficient of correlation. And the third one is Spearman's coefficient of rank correlation. We will discuss about scatter diagram and Karl Pearson's coefficient of correlation in the present video. In scatter diagram, we just plot the values of x and y in a graph and look at the line. If it is straight line like this, then that means it's a perfect positive correlation, and in this case the value of R is going to be equal to 1. So in case if the slope is negative, like for every increase in x the y is decreasing consistently, then that is a perfect negative correlation. And in this case, this arrow is not the line, it just shows the slope of the line I would get if I try to draw a line like this and try to connect as many dots as I can. Then that particular line will have a slope going upwards. So that's a positive slope. It is not a perfect positive, but it is a value that is greater than 0. R's value will be greater than 0. So here we can see that the points cluster around a line with the positive slope, and in this case the points cluster around a line that has the negative slope, and in this case the R is going to be less than 0. And here you can see that there is no relation between the values of x and values of y whatsoever. So in this case the value of R is equal to 0, indicating that there is no correlation between x and y. They both are independent of each other. And in this case we can see that there is no linear growth. For every increment in x, y keeps incrementing till this point. After that it keeps descending. So there is no linear growth, and in this case, value of r is anywhere between -1 to 1, and but r is not equal to 0. There is a correlation, but the correlation is not linear. That is the first method using the scatter diagram. We do that plotting the values of x and y in a graph and observing the slope of the line that connects the dots. Next, we will see how do we measure the coefficient of correlation, that is R, using Karl Pearson's method. So before understanding the formula that is proposed by Karl Pearson's method, there is one more concept we need to familiarize ourselves with, that is covariance. We need covariance to calculate coefficient of correlation, and the formula to calculate coefficient of correlation R is equal to covariance of x and y divided by the square root of variance of x into variance of y. We can also rewrite this as square root of variance of x into square root of variance of y, and square root of variance of x is equal to sigma x. We know the variance formula, variance is equal to sigma square, right? So using that formula, we can simplify this formula into this. So finally, we get the expression covariance of xy divided by sigma x into sigma y. So before proceeding, let's understand what is covariance. Covariance is the measure of variance between two variables. Covariance gives us the measure of variance between the two variables. Why we cannot just do with covariance is because covariance does not show us the relationship exactly, because the unit of x could be different from the unit of measurement of y. That means if you consider temperature and pressure, pressure is measured in Pascal and temperature is measured in Kelvin. So we cannot take a value that combines two different units of measurement into one answer, and we cannot decide the correlation just with that. That is, we need the correlation. Covariance gives us the direction of the relationship, whether it is a negative correlation, positive, or whether there is a negative relationship or positive relationship, that can be understood by the covariance. But we need the correlation to actually find out the strength of the relationship between the two variables. It always varies from -1 to 1, so we can say whether it is strong or weak or neutral. But in case of covariance, it can vary from -infinity to +infinity. So covariance alone will not give us will not describe the relationship between the two variables. That is why using covariance we calculate correlation. The formula to calculate covariance is this, where x and y are corresponding values of two series, and x bar and y bar are the means of series x and y respectively. N is the number of values in the series x and y. They both will be same. To calculate correlation, we divide the covariance by the product of the standard deviations of x and y. If we substitute the formula for covariance of x and y into this, we get this representation, and this is sigma x is 1 by n into sigma x minus x bar whole square. This is the formula for raw data, so we have just substituted that value here. And to simplify this, we multiply both the numerator and the denominator by n square, and we end up with the representation like this. So this is the basic formula of coefficient of correlation, coefficient Rxy. Rxy means coefficient of correlation between the variables x and y. And this formula is used for raw data. So you know that there are different types of data: raw data, grouped unclassified, and grouped classified. So this is the formula, basic formula of coefficient of correlation between the two variables x and y. And in this case, the series x and y both are raw data. There is no grouping or there is no classification. And this is the direct method. There is no assumed mean here. And this is the formula for direct method for grouped data, which involves only frequency. We can also use this formula to simplify problems on classified data. But since in classification we get the interval, we have one more data that we can make use of. So we always use step deviation method whenever the classification is given. Here you can see the difference between these two. There is not much of difference. Only one more extra summation term is added here. And everywhere we have added the frequency term. And this is the formula of assumed mean method for the raw data. In case of assumed mean method, we replace x and y by u and v, where we take u as x minus some value, some arbitrary value in the series A, and v as y minus some value, some arbitrary value in the series y. So here this is called assumed mean method for the raw data, and this is the formula to calculate the coefficient of correlation between the variables x and y for classified data. So here, just like the formula for grouped data, we have one more summation term, and same, everything is same except for we have replaced x and y by u and v, and in this case u is equal to x minus a divided by c. So this interval is different from this one. This c and this c are different. This is the interval of class x and this is the interval of class y. So we have replaced all x and y by u and v, and this is called as step deviation method because we are dividing the difference between the variable and the assumed mean by the class interval, and that's why this is called as step deviation. Those are all the formulas we will be using in the problems to solve now. Look at the first problem. It says in a bivariate data. So first of all, what is bivariate data? Bivariate data is a data that involves two variables that are dependent on each other. Here variance of x and variance of y is given. Also covariance is given. We have to substitute those values in the first formula that we started out, and we substitute those values and we get the value 0.988. So when we get the value r equals 0.988, we can say that this is a positive correlation because it's not 1, but it's a pretty strong, close to 1. There is a positive correlation between the variables x and y. And in this series, we still have raw data. So we can simply write the formula for raw data. And so we will have to calculate the terms sigma x, sigma y, sigma xy, sigma x square, sigma y square, and substitute in the formula. So we get those values, and when we substitute we get the value 0.556. This shows that there is a moderate degree of correlation between the variables x and y. In this case, we have taken the same problem but with a different approach. Here we have taken the formula for assumed mean method. Here the formula is almost same except for these u and v. We have replaced all the x by u, all the y by v. So what is u here? U is equal to x minus a. What is a? A is any arbitrary value from the series x. And what is b? B is another arbitrary value from the series y. And we calculate u and v, and then uv, u square and v square, because we need all these terms to calculate the coefficient of correlation. And then we substitute those values there and we still get 0.556. There is no difference between the answer that we got in direct method and assumed method. This is the last problem we are going to discuss about. Here x is a class of profits and y is a class of sales, and x is measured in terms of crores and y is measured in terms of lakhs. There are 4 values in x and 5 values in y. This is your y series and this is your x series. So all this data, they are products which got sold under each category. So here 1 is the number of items that got sold for 80 to 90 lakhs. 3 is the number of items that got sold for 90 to 100 lakhs. Here we have written dash here because there is no sales for this category. So there is no product that got sold between 80 to 90 lakhs contributing to this profit. So all these are profits and these are sales. First row is the contribution to a profit of 50 to 55 crores. Second row is all the contribution to the profit of 55 to 60 crores. So here, when you solve it, first of all, we have to draw the table so that we can get the values of all the terms we need in the formula. There are 6 columns here. Until 6 columns, it's the same as the problem given. Later, This part is the part that describes the profits, and this part describes sales. So all the values in profit are written vertically. All the values of sales is written horizontally. For efficiency, this is written like this. Here, F is frequency of X. That means all the sum of this particular row. So 1 plus 3 plus 7 plus 5 plus 2 is equal to 18. That's why we have written 18 here. So the same follows 4 rows, and the same way we calculate X. How do we calculate X? This is the mid value of this class interval 50 to 55. 50 to 55 mid value is 52.5. So we have written 52.5 here. Then we calculate U. How do we calculate U? U is equal to x minus a divided by c. I've selected my arbitrary value to be arbitrary mean to be 52.5. So I'll be considering 52.5 throughout these 4 rows. Then we calculate FU. FU is the multiplication of frequency and this value. So 18 into 0 is 0, 27 into 1 is 27, so on. So U square will be the square of this value. 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9. So that's why it is written so. Then FU square is a multiplication of 18 into U square. So 18 into 0 is 0, 27 into 1 is 27, so on. Then we will discuss how do we calculate the sum of FUV. It goes the same way here too. So here frequency is equal to all the numbers, all the numbers vertically here. 3 plus 4 is 7, 7 plus 5 is 12, 12 plus 3 is 15. So we have written 15 here. So frequency is calculated vertically here, and it was calculated horizontally here. And here we calculate V. V is equal to Y minus B divided by D. So what is B here? B is an arbitrary value in the series Y. And what is Y here? Y is a mid value between the upper and lower limit of sales. So 80 to 90, the mid value will be 85. 90 to 100, mid value will be 95. So we have written all the mid values in Y. And we calculate V. It is V here. It is not showing, but it is V. V is equal to Y minus B divided by D. And in this case, just like how we took the first value here as X, we can take any value among these Y values as an arbitrary value. So arbitrarily, I'm choosing 85 to be my assumed mean, and I'm using this formula Y minus B divided by D. I calculate all these values, and then FV, V square, FB square, all the same way how I did it for the profits. So once I do it, once I have all these values, it's time to calculate sigma FUV. You may observe here sigma FUV has the value 382. Here also it is 382. Sigma FUV in both the cases, X and Y, it will be 382. So we calculate sigma FUV based on these values that are written in the corner. So how do we get those values? We multiply U with V. Every U with V. So 0 into 0, we multiply U with V and then that value with the cell value here. So 0 into 0, 0 into 1, 0 into 2, 0 into 3, 0 into 4. And those answers will be multiplied with individual cells. So 0 into 0 is 0. 0 into 1 is 0. So I write 0 here. Since this is 0, all the terms that will be multiplied, that will also result in 0. And those terms multiplied with these cell values will also result in 0. So it's all 0 here. So next, 1 into 0, that is 0. 0 into 2 will be 0. 1 into 1 will be 1. 1 into 4 will be 4. Then 1 into 3, 1 into 2 will be 2. 2 into 10 is equal to 20. 1 into 3 will be 3. 3 into 7 will be 27. 1 into 4 will be equal to 4. 4 into 4 will be equal to 16. What we are doing here is multiplying each of these values under U with each of the values of B, one by one. So first we multiply all these values with 0, then we multiply all these values with 1, then we multiply all these values with 2, and so on. And then we write respective values at the top corner for all the 4 rows. Then all these values will be added and written here. So here sigma FUV is the summation of all these values written in the top, that is 0, and then if you sum all of this, 0 plus 4 will be 4, 4 plus 20 will be 24, 24 plus 21 will be 46, 46 plus 16 will be 61. So all these values written on the top of the cell added together will be the values that will be written under sigma FUV. The same way, it is written vertically here. 0, 0 plus 0 plus 0 is 0 here. 0 plus 4 is 4. 4 plus 10 is 14. 14 plus 9 is 23. So 23 is written here. So all the values will be added vertically and the values written here. So finally, what value we get if we sum all of this, that will be sigma of sigma FUV, right? That will be same for both the cases. So once we have all the values, we can substitute those values in the formula, and that is done here. So sigma of sigma FUV was 382. N is equal to 100. N is nothing but the frequency. This frequency. So it will be same for both Fx and Fy. So it will be 100. Then substitute all the other values, you get 0.094. So there exists very low degree of positive correlation between the variables x and y. So this is how we solve problems based on coefficient of correlation. So in today's class, we studied about correlation, the types of correlation, and the methods of measuring the correlation. And among those methods, we have studied the scatter diagram and Karl Pearson's coefficient of correlation. In the next class, we will be studying about Spearman's rank correlation. So I will see you in the next class. Thank you.